All right, let's say you were asked to find the trig ratios at this angle right here, and they do it by giving you a point. So you have this particular angle, and you know that it passes through. And what would be one possible set of coordinates that would represent this point based on positive and negative signs of the coordinates? So what do you know the x-coordinate has to be at this point? It has to be a negative. So we could say negative 4. Yeah, let's say negative 4. And then what would be a possible y-coordinate for that? 4. Let's to make it so that it's not just like on that 45 or reference angle, the 135. Let's take negative 4 and 3. Okay, if you had to find all the trig ratios for this angle, what we're going to do is we're going to use as our reference angle this angle right here, right? So all we need to do is find the trig ratios for this reference angle. Well, what is this distance here? Well, it's 4 in the negative direction, right? Distance-wise, it's just a 4, but when we're setting up these trig ratios, we are going to use the sign for it. So we are going to think of this as negative 4. And what's this height? 3 in the positive direction. So when you set up your trig ratios here, you have sine, cosine, and tangent. And I'm just going to do these 3, but you guys will probably have to find all 6. Okay, so the sine of this reference angle is opposite over hypotenuse. Well, what is our hypotenuse here? It's a 5, right? It's a 3, 4, 5 common triple. So this hypotenuse is always going to be a positive value. Okay, you guys get that? Okay, that's key to the signs on these. So here when we set up for our sine ratio, opposite, which is 3, a positive 3, over hypotenuse 5. What's our cosine though? So here the negative 4 over 5, the negative plays a role. This negative sign plays a role here. And then what is the tangent? 3 over negative 4. When you're entering these, even though the negative falls in that denominator, don't write it there. Write it as negative. Always put the negative in the top if I give you a fraction. Okay? And if you're just writing it out as a ratio, put the negative up with the top number. Okay? So negative 3 over 4. All right, so what's going to happen if I give you, let's say, this angle right here, and I say it goes through, let's call this the point 5, 2, or 5, negative 2. Okay, how would you find the trig ratios at this angle, which again can either be this negative angle or this full rotation across? Either way, you're going to use the reference angle to find it. Connect that terminal side to the x-axis. So this distance right here is 5. This distance here is 2 in the negative direction. So what's the hypotenuse going to be for this triangle? 29, good. So 5 squared plus negative 2 squared is 29. So take the square root of that. It can't be simplified any further, so that's what you have. And now when you find the sine of this whole angle, again, this whole rotation or this, you are again using just this reference angle. And so the sine is opposite, negative 2, over hypotenuse, root 29, which when you rationalize, move the radical up and just take whatever's out or inside the radical and put it in the denominator. The cosine is going to be adjacent 5 over root 29. And then finally, the tangent is going to be opposite over adjacent, so negative 2 over 5. So do you see how the negative signs play a role depending on where the coordinates fall?